Greetings, everyone. My name is Brian Benz. I'm a cloud advocate with Microsoft, and we're here with Ian Hellen today. We're going to be talking about MSTICPy, which is a cool tool for using Jupyter notebooks for security and threat intelligence. Also, it uses some services on Azure, Azure Sentinel, and a few others. Before we get into that, I do want to invite the folks of you who are joining us on the Microsoft Developer YouTube channel to come over to LearnTV, aka.ms/LearnTV, if you want to ask any questions. It's a live broadcast, so we'll be taking questions live. Please do join us over there, and there's a chat, and you can share and ask questions. So thank you very much, Ian, for joining us, and it's great to have you here. Do you want to tell us a little bit about yourself?
Yeah, thanks very much, Brian. It's a real privilege to be on the show. Ian Hellen, I am a developer in the Microsoft Threat Intelligence Center, which is part of Azure Security, but we work with a lot of product teams throughout Microsoft. I'm one of the maintainers of MSTICPy, which is a toolkit. That's what subject matter today, a cybersecurity toolkit, mainly for use in Jupyter notebooks. We work pretty extensively with the Azure Sentinel team on helping develop detections, and the notebooks feature that's part of Azure Sentinel is one of the main things I work on.
Great. Well, this is going to be a great show. I think there's a lot of information that I want to learn during the show myself. I know you were at PyCon last week, and you had some, not announcements, but you shared the new MSTICPy tools and everything there, and hopefully that went well.
Yeah. It did go well. We just actually released, although MSTICPy has been around for maybe nearly 3 years, we just released version 1, so we're no longer a beta product. So that was quite a nice kind of little landmark.
Yeah. Cool. Well, great. Yeah, well, I'll let you get into it. I'll let you get into just explaining it, and if we have any questions, I'll jump in, and we'll see you later. Thanks.
Okay, thanks very much. So I've got a couple of slides at the beginning, and most of the session is going to be in Jupyter notebooks, but I thought some nice graphics would be a kind of good thing. And I'm clicking, but nothing's happening. There we go. So we're going to have like two main parts. There's a bit of an introduction in the slides, and then a quick tour through MSTICPy, and looking at some of its typical application in a security operations center. The second part of the talk is going to be more deep diving into extending MSTICPy, things like building queries, creating pivot functions, looking at some of the settings that you might need to deal with if you're using the package. So it's pronounced MSTICPy, even though it's spelt rather oddly. As I said before, it's tools for cybersecurity investigators. Open source, Python, free, mainly targeted at Jupyter notebooks, but most of the functionality also works in straight Python if you wanted to call it from another library. As I said before, we just released version 1, and actually we've just last week released version 1.1, so it's kind of moving all the time. And it was originally developed mainly for use in Azure Sentinel, but it's mostly data source agnostic. So we have like support for Splunk and Microsoft Defender as kind of data sources. So now the graphics that I've been messing around with, I kind of discovered doing this that even though this library has evolved organically, it does kind of have an architecture. And I want to it helps to kind of break it down because there's quite a lot of stuff in here. So the first part is a data layer, so a set of data providers, each of which comprises a driver. And you can see there the examples of Azure Sentinel, Microsoft Defender, Splunk, but they work very, very similarly, and we'll see some examples of this in the talk. And there are also a couple of drivers for things like local file data and other captive data sources like mordor, which I'll explain a bit longer. The next area is enrichment, and this is like given something like an IP address or a URL or a domain, give me more contextual information about it. So it might be threat intelligence, where you want to find out, is there something bad associated with this IP address? Has it been used as a source of attacks? through to more simpler things like geolocation of an IP address, or who owns a particular domain. The next section is analysis. So here are the things like anomaly detection, time series, clustering. We'll see examples of a couple of these things in the Jupyter notebook part, and a few different utilities like decoding base64, like obfuscated commands, which is very common with attackers. The final part is visualization. So this is kind of key, like event timeline, and we'll see a lot of these. So event timeline, time series anomalies, visualizations, process tree, kind of things that make it easier for the analyst to understand the data they're looking at, and a whole bunch of little widgets, which is just like helper things for time ranges, browsers, things like that. One thing we have, so this is our kind of application layer. This is like the main way that people interact with the thing. But one thing we've been working on recently is, because as we've been developing this thing, there's lots and lots of functionality scattered throughout the package. So we tried to more recently build more a kind of framework. So how can you discover and use all this functionality in an easier way? We'll look at some of these things: pivots, entities, pandas extensions, and notebooklets. I won't describe them here because I cover them kind of later on. So that's MSTICPy in slideware, and it might not be quite as pretty, but now we're going to switch to Jupyter Notebooks, and here we're going to be using Visual Studio Code to demonstrate them, but these work in any kind of Jupyter environment. Okay, let me switch to Zen mode. So an overview of like the first part, we're going to be looking at data providers and queries, how you get data into a notebook, and then a kind of run through of like how you might apply some of MSTICPy functionality to security operations. You can get a copy of this notebook if you go to aka MS MSTICPy launch space. These are also included in the show notes. So the first thing we need to do, pretty common in our notebooks, is an initialization thing. We've built this init notebook function that basically does just things like import a bunch of things that so you don't need to do it yourself. Things like core, things like pandas, but also many of the items in MSTICPy. So data may be a bit dull, but there's a couple of quotes there that I really like. It's the foundation of all security investigations. If you don't have data, you don't have the log files, then you can't really do anything. So each of the data providers we have comes with both a driver and a set of queries, and pre-built queries are really kind of important for analysts just to speed up the work. You don't want to have to like handcraft a query every time you want to find out who's logged onto a machine or to your cloud service. So we're loading, this is what, typically you only use one of these at a time, depending on your service, but we're loading kind of 4 here for Azure Sentinel. The ones we're going to be using in this notebook are the Azure Sentinel one, and this kind of special one, which is more for demos, but also useful for local data. This just reads data from local files. We built browsers for quite a lot of our, particularly where we've got lots of functions and things like that. It just makes it easier to navigate around and find what you're looking for. Whoa. So this is our query browser, and each of these has like help associated with the query. You can see some of the kind of Linux queries. It also gives you a text of what the query is going to do, along with the different parameters that you can substitute into it. And I just wanted to find a more complex query. This is a kind of an example of something that you wouldn't want to have to type in every time you wanted to find logon failures on a machine. So how do they work? Well, they just work as Python functions. So this is our query provider that we created in the previous cell. The queries are divided into categories. So this is like network query, and this is the name of the function, get network summary. And I'm just, the head part is just, so I don't fill up the screen with lots and lots of rows of data. So that's pretty much how they work. Now, most, apart from like local data, pretty much everything will need an authentication step, most query providers. So this is the Azure Sentinel one. The Splunk one works a bit differently, it has like username, password, server as parameters. So now we've just connected here using Azure Active Directory to our workspace. We can start kind of running queries. So most queries also have mandatory parameters. The one I showed you a couple of cells back was something that ran without any parameters. But if we try to execute one, then it will tell us like the missing parameter and also give a full rundown of what parameters this particular query accepts. And if you execute the same query with the supplied parameter, then it does what you would hope and returns the data. So most queries also require time parameters. Kind of, you would expect that, you know, given you want a query for data for a certain time range. And one of the things about this is probably the most awkward kind of thing to type in, particularly if you want to be accurate. You might have a set of queries that have a whole set of time parameters. Then you use the same queries for a different time range. You've got to like copy and paste into that time parameter throughout the queries. So this is one of the widgets I mentioned. Very simple. One of the first things we built in MSTICPy was something that allows you to kind of manage time ranges and then apply them to queries easily. So if we take that time range, we can just plug it into a query. Now this query really accepts start and end, but the time range has both of those values inside it. So the query will pull out the start and end of the range and will execute the query as if we'd supplied the required start and end parameters directly. Most of our queries have this special parameter, add query items, and this is somewhere where you can just tag on anything that you like, really, anything that the query language, underlying query language supports. So we're running the same query here, but adding the additional filter clause for processes that just contain PowerShell. And here is where my zoomed in screen doesn't help me, but if I can find the process name, you can see that it's just PowerShell, as you'd expect. There's also a pass-through FunctionExec Query that you could just craft your own query and supply it as a string. If one of the built-in queries doesn't help, or extending a built-in query isn't helpful. So all of these things you might have guessed. Some of you maybe who are familiar with data science and Python, Jupyter Notebooks, the use of this head thing here was probably told you that being returned from each of these queries was a pandas data frame. And pandas, if you're not familiar with it, is you can think of it as a bit like a programmable Excel spreadsheet. Like it has rows and columns named, and you can do lots of operations on it. It's very like used kind of throughout the Python data science community. And importantly, this is what MSTICPy uses as inputs to functions, outputs to functions, and sometimes both. So we use it as a kind of ubiquitous data format to communicate between different parts. So if you don't have a scene like Azure Sentinel or Splunk, you can still use most of the MSTICPy functionality. I mentioned earlier mordor, which is created by a couple of friends, colleagues of mine, Roberto Rodriguez and his brother, Jose. And this is a great source of data for like sample attack data. And actually we have a mordor driver that you can pull data directly from mordor into MSTICPy. You can also read things directly from CSV files. This is nothing to do with MSTICPy. This is pandas' amazing abilities, CSV files, JSON files, lots of other things. But having that data frame from a local file doesn't stop you using a lot of the MSTICPy functionality. And I mentioned, I think, in the opening slides, pandas extension. So this is an example of a pandas extension. You don't have to import the MSTICPy timeline. It's just dangling there at the end of your data frame if you want to use it. So this is what it looks like. And the value of stuff like this is like a really commonly used tool for security analysts. Something that's not apparent from just seeing rows of data on a screen, for example, is the pattern of the activity here. So you can see there's a lot of like closely grouped processes happening this time, and then 2 hours later, somewhat sort of stretched out set of processes. So it's kind of odd that there's a gap here, and the fact that these are packed together probably means it was a scripted attack because they're very, very short timeline between them. You know, we can kind of zoom in and have a look. A lot of them happen like very, very closely together. So as well as that being something you can see from timeline, you can also do different kinds of pivoting on the data. So we can group it here, and we can see exactly what these different processes were that were run very closely together. It looks to me as if these are things that the first burst of things that actually did something, some kind of attack. And if you look at the ones later on, they're things like killing tasks. Could be that the attacker did something in this first part and then came later on, either a scheduled job possibly, or just logged in and just to clean up the things they've been left lying around. Okay, so MSTICPy with CSVs. So now I want to get into the kind of main part of the first part, which is a tale from a security operations center. So security operations centers are all about responding to signals. These could be alerts or anomalies. And what you need to do is get contextual information, like finding out what is this signal indicative of an attack, or is it just some kind of benign admin operation that we can just close it? And if it is indicative of an attack, how do we investigate the targets of that attack? So we're going to be using a component from our anomalies toolset, the analysis toolset, in particular the Timeseries decomposition. So seasonal trend decomposition using Lewis. Now you don't need to know what that means in order to use it, or even how to spell it or anything like that. We're just loading two libraries, one which is something that will do the analysis, and the other one, two functions, sorry, and the other one that will display the results. Now we've got some prepackaged data here that is already has the data grouped by hour. This is a kind of thing you would want to submit to this sort of analysis. Typically, you don't have that. You would need to go back to the raw data, either from your query or using pandas to group. Like in this case, we're using total bytes sent. We've summarized for each hour the total bytes sent, but this could be summarized as failed logons or some other kind of thing you can quantify. So that's the data we're using. We send it to our, first of all, the analysis part, and then display the results. And this is what Timeseries decomposition does. It builds a pattern of seasonal trends, and you can see here that there's a lot of activity during the day. It's fairly quiet during the nighttime, and so on. You can see the 5 days of the week, quieter at the weekend. And what you can see here is like there are two kind of outlier anomalies identified, looks like late on Friday, where the traffic suddenly doubles compared to the seasonal average. So we could try and work out roughly what the time range there. We want to focus in on that particular time range and see what's happening. We could try to work that out from the graph, but we obviously have a function that will pull that out. We want to minimize the amount of guesswork. and he just selects an hour each side, and so we can then use that time span against our raw data, which looks a bit like this. What we want to do is find out who was responsible for that sudden burst of traffic, and was it something interesting? So, assuming that's our raw data, we can run that query again, but for the specific anomaly period. And then we're going to display the results. We're going to split it into group by source and destination IP, and summarize the amount of traffic between those two endpoints, and then display the top offender and a comparison to all of the other people that were talking on the network. And we can see it's very clear here that there's this pair of IP addresses were responsible for this spike. Okay, so we have a couple of IP addresses. We can probably assume that this is an internal IP address of some sort, and this is the external address. But how do we find out more information about it? So this is where the enrichment functions come in, like getting to know your subject, providing more kind of context. So at this point, I want to introduce a couple of characters into the story. Entities, first of all, are kind of like the nouns of the cyber world. So let's have a look at some of them. This is just printing out our some subset of other entities that we are familiar with. So account would be a good one, a domain, a file, IP address, things like this. So they're kind of they're the jigsaw pieces of most attacks. And this is an example of an IP address, very simple class that just has a single address property. Some of these things have more properties. So these are the kind of pivot points, if you like, of our analysis. The second thing I want to introduce is pivot functions. And you may remember I mentioned these in the slide. This is a kind of a bit of a blurry graphic, but pivot functions, if the entities are nouns, then pivot functions are like the verbs. So given something like an IP address, there are a whole bunch of operations we can do on that. Things like discovering where this IP address was located, or is there any threat intelligence data that's relevant to it. And we built these pivot functions, as I think I may have hinted at earlier, to give you an easier way of getting to many of these kind of functions. You don't need to know what to import. So they're just anything to do with an IP address. It's just there as a function that's attached to the IP address object. So let's look at some of these. We're loading our pivot library, and this will do the job of attaching the functions that we have within MSTICPy. It includes queries that are relevant. So let's have a look at a simple one to get a hello. Let me try that again. My mouse is not responding on there. Well, let's look at a not simple one. So some of these are queries. There are other things. So these are all the queries, Azure Sentinel queries, and down here you can see a Microsoft Defender query that are related to an account. So the sign-ins that happened on the account, or alerts related to the account, that kind of thing. So let's look at an example of these things in operation. So we have an IP address. This is our suspected attacker address. We can use the whois pivot function to get this retrieves the subnet that this was part of and who is the owner of that subnet. That's kind of, well, maybe interesting, maybe not. We can use the same pivot function and send it a whole set of IP addresses. So this was our set of noisy IPs that we had in our earlier graph from the time series analysis. All of the IP addresses that were involved in that suspect time period. We get a whole bunch of these things, and here we see most of these. They look like Azure addresses. But there's one of our suspect addresses appears to be something different. So that might tell us something straight away, that this is unlike the normal patterns of communication. We can also look at the source IPs. In most cases, we don't get anything very interesting here because most of these source IPs are private IP address space. There is one at the bottom, which is the other end of our communication. We see that also looks like it's an Azure address. Other kinds of pivot functions, we can use the geolocation function to find out where this IP address is, somewhere in Los Angeles. It's kind of okay, but it's nicer to be able to show these things in a visual way so that you, similar to the event timeline, so you have a different view rather than just showing a whole table full of data. We're going to use Folium Map. I actually executed that a little bit too quickly. Folium Map, which is a mapping Python package, really, really useful. And we've taken both our suspected attacker IP and all of the other IPs that were kind of communicating at the time and plotted them on a map. And if we zoomed in, or if we had a good enough resolution for our, for some reason my mouse has stopped working. I wonder if that's something to do with the screen sharing. If we could have zoomed out, we'd see the other IPs on there in a different color. Okay. So one of the most useful tools in the analyst's arsenal is threat intelligence. So these are external, many companies like VirusTotal, X-Force, RiskIQ, a whole bunch of people, Mandiant FireEye. The result of investigations or maybe detonating malware, they find reports on things like IP addresses, URLs, domains, files, and can often, if something you're investigating like an IP address turns up in one of those data sets, then you're pretty you will know that there's something bad happening. So here we're looking for our IP address using another pivot function that just does the TI lookup. And here is a kind of browser widget. So we're just looking at the results of that, but rather than in a pandas table, we're kind of presenting it in a more readable form. And here we can see this looks like a exploit kit that's associated with this IP address. So we're pretty convinced that this is something bad. What we want to do now is look at the other end of the communication. So our host in this case, and what was communicating with this known bad IP address. So here I just want to introduce Notebooklets. These are kind of aggregates of notebook cells. So you can imagine all of this code that we've just been running. If you were to do that frequently, it's much easier to have that as a single package, a single function, rather than having to copy and paste the code to do all the analysis as we did with the IP address. So we've done that in quite a few cases. We've done it also with the IP address. A few different notebooklets, count summary, host summary, IP summary, and we'll see some of those in the next few cells. Now, one thing to note before we start, if we look at what happens here until the end, it looks like quite a lot of code, but not a huge amount. And I want you to kind of compare the amount of code that we're running with the output. So most notebooklets, not all of them, but most notebooklets use a time range. Yeah, something weird has happened. I can't actually select the time range. Let's see what happens if we just use that. Yeah, I can only think that must be the screen sharing, so it worked perfectly 45 minutes ago. So let's try and have. No, that's not good either. Yeah. Okay, that will work. So we're basing it on our anomaly times that we got from the time series analysis, but expanding it a little bit. And we can run our host summary. This just gets basic information about host, tries to find out whether it's a Windows host, a Linux host. It will, if it's an Azure VM, try to sign in and get VM details. And so we know the subscription owner, we know something about it, what it's a Windows machine, for example. It's also gone and searched to see if there are any alerts that are fired on this host and produced a timeline. We can have a look at the individual alerts. And again, this is kind of a, well, if it wasn't for my screen sharing problem, I'd be able to click on one of those and show you that it changed. But it's an alternative to the kind of data frame view where you're often struggling to see stuff in restricted columns or off the screen. So we give you a browser to kind of look at this in a bit more detail. We have a couple of other notebooklets, one that just produces Logon Summary. So this is who's logged on to this machine, were there any failed logons, where did the logons originate from, kind of heat map of different the different types of logons and whether it was a failure. There's one here that we see as a high number of logons and a few failures. So it could indicate a kind of, somebody retrying and eventually breaking into the account. We could scroll down the screen rapidly because I'm kind of overusing my time a little bit. We've also have an account summary. So we noticed Ron HD was one of our frequent logon people. We might want to have a look at what Ron HD was doing. And this does a similar thing, but for accounts. It looks at is this a Windows logon? Is it a Linux logon? Is it an AAD kind of logon? And finds more information. The last logon recorded, and also it's found a number of alerts, which we can look at. I won't do that for reasons of time. Final thing we want to do is look at the processes on the host. And notice here for that time period, there are lots and lots of processes, 23,000. Nobody wants to look through that amount of processes. So we can analyze those processes and group them into logon sessions and use clustering to estimate the rarity of a process. So if I scroll off the screen a little bit, you can see a lot of these processes are kind of pretty boring. They're like system things. Really, we want to remove a lot of those things and just try and focus on the very unusual processes. So this final notebooklet will help us with that. It's calculating the relative rarity of each process and command line.
Hey, Ian, while that's calculating, we did have one question, if you don't mind.
Sure.
So Jose Silva, over on Microsoft Developer YouTube channel, says, can we use SciSharp and its components in this Jupyter notebook?
I'm not familiar with what SciSharp or SciSharp?
It's SCI and then Sharp, SHARP.
SHI Sharp.
Yeah. Well,
not C Sharp.
No, SciSharp. Jose, if you want to just, okay. Yeah. So it's Aaron's popping in. It's a .NET based open source ecosystem for data science, machine learning, and AI. It's sound is something that, as everyone knows, the Python world is big and wild, and this is something I'm getting the feeling Ian hasn't.
I've never come across it.
Yeah.
My world is pretty narrow. The rest of the world is like big like this. So here are the results. What we've done is calculated the rarity. I mean, I could try and investigate that if you wanted, like maybe after the show. So it's calculated the relative rarity of the processes and then grouped the logon sessions here. This is different data sets, so the usernames and host names are different, but just to show you the principle. And it's found that this one has a relatively high proportion of rare processes, whereas down here, the vast bulk of our processes are very boring kind of system processes. We're probably happy to eliminate them. And there is a chart there, but I really wanted to show you, if we look at the process tree associated with that, which is part of the same notebooklet, can generate a process tree, and we could see here the order of which things, which were the parent processes, what they were doing in much more detail. And the final two things is we have a couple of processes in here that have obfuscated PowerShell. We can use another utility to decode this. And something weird has happened to the output here, but if you can squint and try and ignore the intervening spaces, you can see there's a web request here to our suspicious IP address. So it kind of confirms now we've got to close the loop and confirm this is an attack, and then kind of get on with it. So we looked at like the network anomaly traffic and used all this kind of contextual information, and then got onto the host just to sort of summarize and kind of finally confirmed that the suspicious session, the account involved, and what the processes that the attacker was doing. This won't be the end of the process for the analyst, but there'll be a remediation looking at the kind of blast radius of like, did the attacker go anywhere else? But it's the end of our story for the moment. But not quite, because what I wanted to do was at least cover a couple of things that were about extending MSTICPy, and two of the most common ones in particular. Let me go back to Visual Studio Code Zen mode. So the first thing I wanted to look at was MSTICPy settings. And I'll spend a very short amount of time on that because it's not very interesting, but as we have added more components, our kind of settings file, this is an example, has kind of grown. We have like threat intel providers, GeoIP providers. They usually need API keys to go along with them. So we've built a little utility, not the prettiest thing in the world, allows you to manage these settings. And this is something you'll probably need when you're first using MSTICPy. So it allows you to kind of add TI providers. You supply the API key. There are other data providers, things like Splunk I've mentioned a few times, where host username, password, and usually the sensitive things you can store in and upload to Key Vault. So that's a good way to kind of manage. If you don't mind editing YAML, please edit the YAML directly, but otherwise you can use that kind of interface. So more interestingly, a bit more kind of code area. We've looked at queries that operate a lot like this. They have a parameter, a return result. And we've already looked at our query browser. What if it works in here? Oh, yes, I'm back. Maybe it's actually something to do with the VS Code Zen mode. So you can see they're all of this kind of format. There's Azure Sentinel, they're kind of categorized, and then there's the name of the query function itself. So how do we get a query function in there? You don't need to write any code, first of all. They're all derived from definitions in YAML files. And each definition file looks like this. There's a metadata section, which has some kind of overall global stuff, including things like description. The most important one is the data environment, and that's the name of the provider. So Here you'd have Azure Sentinel or MDE or Splunk or whatever it was. A default section and then a sources section, and this is where the queries are defined. I think rather than describe them at this level, it's probably better just to have a look at one. So here is a simple, I mean, I say simple, it just has a single query in it. And here we've set the environment to be Azure Sentinel. The data family, custom queries. This is the grouping I talked about if I scroll back up. So these first part before the dot, that's the data family. And you can use whatever string you want. Obviously, it makes sense to kind of group your queries together just to let people navigate them more easily. Down in our query section, we'll come back to the default section. Down in our query section, we have the query text defined, and these things in blue are the replaceable parameters. So obviously dates and other things. And then a parameters block where we define each of these parameters. They can have a description because we like to be nice and friendly, a type, and potentially a default. So if there are things like here, we've supplied a default start time, which is 1 day ago. You don't have to just supply defaults, but where it makes sense, you would do. So let's take this. This is a Python string, and I usually keep forgetting I need to execute that to actually define it. And then we're going to put it in a file. So we're going to make a queries directory, subdirectory, and we're going to save it to this YAML file. This is an optional thing. We're just going to read the thing back and just check that it is actually legal YAML and it looks like, roughly contains our query. So that looks good to me. Okay, so how do we get it into a query provider? Well, we're going to load the query provider again, but this time we're going to give it this additional query path. We'll say, look also in this folder for any YAML files and see if there are any queries in them. So that runs, and then we can list the queries, and hopefully somewhere down this list, we should see our custom queries and list events by ID. Cool. But does it work? Check that. And yeah, well, that's good and bad news. The good news is that our careful descriptions and parameter descriptions made it through into the help text, but we missed a parameter. So let's run it again. And this is going to take a little bit of time because this is searching for all of these event IDs over all hosts in this workspace over a period of a day. So we see it seems to work, and we can make it a little bit narrower with a specific time range. Okay, that works pretty well. If you want that query always loaded rather than having to specify it, you can specify where we had like a local queries path. In the MSTICPy config, you can create a custom entry under query definitions, point it to one or more directories, and it will always try to load queries from there. Okay, I've got another example, which I won't spend a lot of time in, but this is like the purpose of the defaults. So it's the same query that we had before, plus another one. But we've moved a lot of the parameters into a defaults area. So that allows you to specify things like start and end, which apply to most queries just once. And by default, all of the queries you define in that file will inherit all of those things. Kind of running a little bit short of time, and I really want to get onto the pivot functions thing. So this just shows you that these did actually work. And one of the things we did is one of the queries we defined locally a different container name for this. So this appears in a separate container from the default for the file. One thing that's useful for debugging queries is this print. If you put print there, plus all of your normal parameters, it will produce a string, which is your the completed query is what's going to be executed against your data source. And one of the things I've noticed here is I made a typo in the second query. That should be surrounded by quotes rather than parentheses, so that would fail. But this is a good way. You can actually copy and paste that into your normal kind of query console, run it, and see what, see if it's returns the results you expect or breaks. Okay, a couple of minutes I have left. Pivot functions. We've seen these before. And I think this is what I kind of wanted to show you before. So they're categorized in a similar way to queries. This is an example that has like threat intel lookups and just a couple of queries associated with file entities. Whoop, went a little bit too far. So if we wanted to build one of these pivot functions, how would we do it? So here is a very simple function that I want to create as a pivot query. It doesn't do anything very interesting. It just takes a URL and splits it into its component parts and then returns the results as a dictionary. And we can try it on a URL. You can split it into the scheme, the host name, the path, query string. So to get that into a pivot query, we need to do a couple of things. We need to call this add pivot function with the name of the function, which we defined earlier on. And there's a bunch of registration information. So the easiest one to follow is the container that we want it to appear in, so the thing that's before the dot. We need to tell the pivot subsystem a little bit about the function. So we need to tell it that this is, as we can see, the function here, it just accepts a value. So it doesn't accept a string or a data frame, it accepts a value as input, and the name of that input is URL. We can actually rename the function before we add it. So if we find a function that either we didn't write or we thought was named badly, we can rename it when it appears in a pivot function. And that's kind of all we need to do, this pivot registration. You can supply these things as parameters to this function, but it's kind of neater, I think, if you put them into a single class. Did that work? Let's look at the pivots on our entity, and we should be able to see, yes, custutil components. So it's there, but does it do anything? Let's give it a try. So it's split up the component and given us back the components of this URL. And one thing that this original function didn't have was the ability to handle lists of inputs, but by the magic of pivot functions, it now can. We can give it a list rather than a single URL. And not only has it handled all of that input, it's returned the thing as a data frame. So this like a very humble one-line function is now relatively sophisticated, has some sophisticated magical abilities that have been given to it by the pivot library. You can, and you'd probably want to, rather than just defining functions in a notebook, you'd probably want to have these functions, if you use them a lot, in an external module. And this is what we're doing here. We've added an extra function. We're using the Jupyter write file magic to write it to this file, pivot functions. And also, you don't want the registration information to have to type that into every notebook. So alongside this is a functions definition YAML file, which we're also going to create. And these just include mostly the same thing as we had in the pivot registration. There's an additional item here, is the source module. So what the pivot under the covers is going to import pivot functions module, and then it's going to try to get the function split URL out of it. And the same for this is HTTPS. So if we, I need to actually write that file. There we go. Did I write that one? Yep. Now if we register that file, have a look at the pivots, and we've got both of these things. That's kind of cool. And there's our is HTTPS, and that all kind of works well. One thing I didn't mention, whoop, that was my timer to tell me my time is up, but I'll try to include this little bit, was this create shortcut. So this adds, we can see that that's caused the functions also to be added to the top level, so not inside a container. And that gives us a couple of nice features. One, it means that we don't have a extra, it makes the whole function call shorter. But the other thing is, if we have entities like that have property inside them, we don't need to supply any parameters to run it. So it will just pull out the URL parameter from our URL object and just run like that. So I was hoping, if I hadn't talked for quite so long, to talk about creating a data provider, but the code is here in the notebook of how to do that, or at least as a simple example, because we're one of the things we'd like to get is some more contribution of different data providers for different data sources. So feel free to look at that. So we've looked at introduction to MSTICPy, some kind of glossy slideware, but also the overview of it, and some of the ways you could go about extending it. It's still got some rough edges. It's still growing. We're kind of trying to. There's only 2 of us working on it. So that's why we'd like some more external contributors. Things to take away, I would say, is install MSTICPy and Mystic Notebooklets. Try the sample notebooks you can find in the show notes. If you like it, please leave us a star on our GitHub thing. Obviously, if you don't like it, don't leave us a star, or maybe you could do anyway. Try out the MSTICPy lab. We created this for PyCon, and there is swag available, including some kind of Adafruit goodies, as well as like stickers and things like that. There's a more manageable URL in the show notes as well. And whether you're a Python coder or not, if you want to contribute to MSTICPy, you'd be very welcome. Like documentation, query building, anything like that, we'd be super keen on. I have a whole bunch of resources here, but these are all duplicated in the show notes. And with that, I think I'm about done.
Great.
You can open it for questions.
Wonderful. Thank you, Ian. That was really good. I just wanted to mention, you mentioned the show notes. We have a link that we can show you. It's aka.ms/the-launch-space-MSTICPy. It's in the banner. It's also in the chat. So do follow along for that for the show notes. And it's a live broadcast. We've got a few minutes left, 7 specifically. And we have time for some questions. We do have a question. If you go to aka.ms/learntv, you can ask questions of us here. The first question we have is from Mehmet. He was concerned about the APIs having 100,000 result limit in terms of returning results. I don't know if you've bumped into this before, but he was asking if you can get more data via MSTICPy with Sentinel 365 and other things like that.
Yeah, so one of the things we did build into our query, I think he's talking about queries, so like the Azure Sentinel query limits, timeout, and results. So that's something I didn't show you, but our queries also support actually I can't remember the name of the parameter, but you can add a parameter to split the query into like split by, I think it's called like split by, and then put a period. So say you have a 30-day query, that's probably never going to execute and return, but the split by 1 day or split by 1 hour, it will chop the query into little bits, and you might need to go away and have lunch or have a coffee for it to complete, but at least it will complete. It won't just time out and die.
Sweet. That's one way to get around. Great. That's wonderful. I had some questions as well. You mentioned contributors. You're looking for contributors. What specifically are you looking for from contributors? Should they be Python aces? What do they need to know to contribute? Well,
we're very happy for Python aces, but you don't have to be. So some of the examples I've done of like pivot functions and shown you queries is a really good example. You don't need any coding knowledge at all there, but some of the providers we have could do with a bit of love. So an interesting set of queries for Splunk, or more for like Microsoft Defender and other things, that would be a great thing. We're also always, because again, there's only 2 of us, we're always kind of struggling to keep our documentation up to date, and we'd like to write some kind of tutorials and how-tos rather than just the reference documentation that's there. We've got a lot of user guide documentation. It's not just APIs, but somebody who would like to contribute there would be also like super useful.
Great. No, that's really useful. Yeah, that sounds like a call to action for any third-party providers out there. Add your, add a connection.
Oh yes, yeah, that would be super cool, because we did have a contribution from a couple of months ago from VirusTotal. They gave a really nice kind of library to support their V3 APIs. We're also talking to RiskIQ at the moment. They're very keen to they've got a similar kind of Python library, but they'd like to kind of have it wrapped inside MSTICPy, exposed through pivot functions and TI providers. So anything like that, we're just super keen on.
Great. So those are the partners you're working with. And what about in the cybersecurity space then? Are those the partners in the cybersecurity space, or are there others you're working with?
Yeah, well, some partners we've taken without their knowledge. So people like MaxMind using their GeoIP, mostly free public accessible data sources. VirusTotal, we were just using their API without their knowledge. Until recently they've kind of become a partner now. And gradually we're being approached. So we're still kind of a little bit unknown as Python libraries go. The cybersecurity world is even a smaller subset of the Python world. We're kind of being approached by more people who want to kind of integrate their stuff. We had Sumo Logic, kind of data provider, another Azure resource graph data provider. So that looks like it's kind of turning the corner, and maybe eventually there will be more than just 2 of us kind of working on this stuff, because it's useful for everybody. I think useful for anybody who's involved in cybersecurity or in a security operations center, or wants to build automated notebooks for their analysts to use. That most of this stuff is valuable. So the more that we can kind of contribute and build a rich repository of this stuff, then the better.
Great. We do have a couple of questions here. One I can answer, which is this session recorded? Yes, it's recorded. It'll be available on Learn TV and on the Microsoft Developer YouTube channel. So you can find that there shortly after we finish the broadcast. The other one, what about just the roadblock? Not roadblock, the roadmap. So I'm reading and talking at the same time. What are you looking at in terms of future versions of MSTICPy? What's the roadmap we're looking at?
Yeah, so we certainly do have roadblocks, but our roadmap, we'd like to get the pivot functionality. We'd kind of like to extend that in a couple of ways, maybe have a simpler syntax.
Right.
So that you can kind of invoke the functions without having to know much about them. So kind of build out more. We still haven't got all our functionality as pandas extensions. So I think pandas extension is typically where you've got a big block of data, and the pivot functions are where you're interested in individual entities. We'd like to make that kind of more homogeneous and so it's better than it was a few months ago, but there's still some way to go. And working with partners, I'm kind of excited about the conversation with RiskIQ and their passive total library. I think that will be kind of interesting step forward. And then we're planning to do more notebooks, which is the other half of our job. We need to create notebooks that actually make use of all of this stuff and show people how to use it. Notebooklets, I think, is all we would like to kind of expand. We'd like to, currently they're all Azure Sentinel specific. We'd like to expand those into other kind of data providers.
Great. Okay. Well, thank you, Ian. That's all the time we have for today. If anyone wants to find links for the show page, on the show page that we've been looking at today, aka.ms/the launch space MSTICPy is is where you need to go. It's here on the banner, and it's also in the chat. So thank you very much. And
Thank you.
yeah, it's great stuff.
Yeah, have a great day.